Alright, so welcome again. This is Chipmaster here in another repair video, and today I will be repairing a MacBook again. Right, so I have a MacBook here that is given to me by a tech. Right, it says that it's not turning on, and it's an A1502. Don't know if you can pick it up on the camera. Let's focus. I can't get it to focus here, really? Let me go back some more. It's not focusing. Alright, so there it is, a A1502, right, and it said that it's not turning on. It's not turning on. Alright, so I'm going to go over to the overhead. So I'm going to plug in the MagSafe. Alright, so I get green and I get orange. Let me press the switch. So as I'm pressing the switch, as you can see, right, so I'm pressing the switch, but it's not turning on there. Right, so I'm pressing the switch, there's no up logo, no chime, none of the other. Right, and the current is fluctuating. Right, the current is fluctuating. Let me see if I can show you on the next DC power supply here. So I'll have to lower the camera. So we'll work with this camera for now. For the DC power supply, I mean. Alright, so there we go. You can see that the current is now trying to get the wires out of the way. Alright, so the current is there jumping, as you can see, constantly. That's all I'm getting. And the current is there fluctuating. Alright, so let's see what's going on inside. Okay, so this is a 2014 machine. The 2015 has the flex for the trackpad over the battery. No, they use electrical tape here to tape down the battery. This is a generic battery. Yes, the battery has been replaced already, as you can see. See? The battery has already been replaced. Alright, so the battery has already been replaced, so I'm going to disconnect the battery. Alright, I'm just visually inspecting at the same time. Right, in the standby area here. Alright, that's the standby area right here. Not seeing anything obvious to say that it has any. As you know, this side is always good, but we have to check the next side. We have to check the next side. So I'll take out the board. Yeah. Alright, so the board is out. Alright, so I'm just checking on this side of the board. Alright, so just some dust at the top edge of the board here. I'm looking down this side. This is dust on this side up here. It's just dust. Not seeing anything obvious. Alright, so there's nothing obvious for the visual inspection. It's just dust. It's all good. Alright, so I will just dust off this part of the board. Alright, so I will have to do some code checking now, checking some resistances. Alright, so I first check the standby, 5 volts, good, 3.3 volts, excellent. PP bus, that's good. Alright, RAM supply, yeah, that's also good. Oh, stupid art. Get some of the light off. There we go again. So 5 volts. Yeah. 3.3 volts. Yeah. RAM supply. Yeah. That's good. CPU core. Excellent. Alright, so this is VCC IO. Also good. There's no fault there. And PP bus. Yeah, check already. Also good. Right, backlight. Excellent. So we have no problem there. So I'm going to connect the DC jack. Oops. Alright, so I'm plugging in the charger now. See what the current is going to look like now. It's the same thing. So it's like, it's a short. It seems like there's a short on the rear stage of the board. It seems that there's a short on the rear stage of the board and it's continuously doing a power failure. Alright, so I'm going to check SLP sus. SLP sus is here, I believe. Alright, that's good. 3.3 volts should be there. This is coming from the PCH after getting the deep sleep well. So once the deep sleep well is activated, then the CPU will internally enable SLP sus. 3.3 volts is here or not. As you can see, it's trying to generate the voltage, but something is blocking it. Something is stopping it. Now I will have to go to the oscilloscope. Let me see how PP bus is generated first. Let me see what's going on for PP bus. The voltage here is a bit too low. Let me up the voltage a little bit. Yeah, right there. Alright, about that is good. Alright, so 12 volts is, oh, it's, right, we have steady 12 volts as you can see. Oops, it's fluctuating right there. Yes, there it is. It's not stable. Alright, 3 volts is okay. 3.3 volts is also okay. As you can see, it's going to 3.3 volts, 2.5 volts. 5 volts is generated. So the board is triggered. The board is triggered. As you can see, 5 volts is generated. This is PP 5 volt S4. Right, this is controlled by SLPS4. So the board is triggered. The board is triggered. So this is a power failure. This board has a power failure. So it triggers on, powers off, powers on, powers off. So this is a typical trigger. It's a protection event, a trigger protection event. Right, so it turns on and turns off. It turns on again, it turns off. So most likely it's sensing a short on the rear stage of the board. So what I plan to do now is to use the oscilloscope to check each rail to see, and I'm going to check if SLPS3 is triggered. SLPS3 is triggered. This one might be a tricky one, ain't it? Oopsie. We're having a problem here. Anyway. Right. So I'm going to check with oscilloscope. Let me remove all peripherals from the board, including the hard drive. Plug in back the power again. It's the same thing. So I'm going to do a 2-channel comparison. Let me get the oscilloscope. Okay, so I'm going to do some comparison with SLPS3. So I'm going to compare SLPS3 with each power supplies, right, to see who falls first, to see if there is a power protection, to see if it's a power rail causing the power failure. Alright, so I'm going to start off with SLPS3. PLTV said all those signals will be compared with SLPS3, APOK and so forth. So let me head over. This is the schematic I already opened. So SLPS3, let me do a search. SLPS3 is from here, right? So this is the PCH section inside of the CPU. Right, as you can see, this is a Haswell CPU. So this is a 4th generation CPU, right? And this is a ULT, as you can see, meaning it's a low-powered CPU from Intel, right? And it only uses this is a low-powered CPU, which PCH and CPU combined. So SLPS3 is my main focus here. PM SLP underscore S3 underscore L, right? And that's my key signal here. As you can see there, it is this one is connected to a resistor for discharging to ground. As you see, that's for discharging, right? So SLPS3 is coming to this AND gate, right? This is an AND gate inside of a BJ package. No, sorry, it's not a BJ, it has legs. So it's going to output VCCST power good, which is the main power good signal from the all system from all power supplies, right? All system power good. PM SLPS3. We have here, this is going to these LEDs. We have it here. This is an alias. Yes, no, it's going to the EC. This is the EC, as you can see, U5000, right? We also have, that's a table, and it's coming to this AND gate as well to produce S0 enables, right? So we have SLP underscore S3 buff, 1.05 volts enable, 5 volts S0 enable, 3.3 volt S0 enable, right? All these are from SLPS3 to turn on the S0 state, right? Which is the S0 enables. We have here, this is a flex connector, and we have here. So I'm going to pick a nice spot where I'm going to solder this wire to do a comparison. all right, so I can put it here. Here, at this resistor here. All right, so that's under the PCH there. All right, so I'm under the microscope now. And SLPS3 that AND gate is here, I believe. This is the resistor. So I will put a joint there. Oh, it's not there. Not that one, sorry. It's here. This is the resistor. Yeah. So the resistor is here. Sorry, this is the resistor here. So SLPS3 is right there. Don't like this idea because if my wire slipped, I can rip out this resistor. So now I normally tape down the resistor, the wire, sorry, and I will just make a curve here. This wire is too fat. I'll use a thinner wire. Okay, so I found a test point here. Nice test point. So that's SLPS3. So I'll put a tape over it so it doesn't shift and tear that lead out, because the weight of the oscilloscope probes can slip and tear. So taping it is a perfect way to hold it in place. If this oscilloscope probe slip, we don't tear out this pad here, this test point there. Right, so I'm connecting the, oops. Right, that's one probe there. Alright, so this is SLPS3 probe, as you can see. So I don't have to worry about anything dragging. As you can see, I taped it down so the signal cannot rip out that pad, so the scope cannot rip that pad out. So I don't have to worry about this. I can have it laying down anywhere. Alright, so now I will check. So I'm going to connect the power. Right, so this probe now will check all my errors. Alright, so I'm going to get the oscilloscope ready. Alright, it's ready. So the blue channel is channel 2 and the yellow channel is channel 1, right? Making sure my probes are set to 10 times. Yes. So remember, the blue channel is channel 2, the yellow channel is channel 1. Alright, so I'm going to give power. So I'm going to first check 5 volts. This is the rear stage of the coil. 5 volts. Alright, so I have to adjust the trigger level, hopefully. Too high? Yeah, too high. Trigger level. Let me go again. Aha, there we go. So 3 volt and 5 volt, SLPS3 and 5 volts is powering down together there. Alright, let me go again. Alright, as you can see, SLPS3. So remember, right? Channel 2 is SLPS3 and hold on. Alright, so channel 2 is SLPS3 and channel 2 is the blue, right? And channel 1 is 5 volts, right? So remember, the blue line here is channel SLPS3, which is channel 2. Channel 1 is each power supply coil voltage. Right, let me see if I can set this to the single. Alright, so as you can see there, so 5 volts is powered down together with SLPS3. Right, so 5 volts is powered down with SLPS3. As you can see, there is no problem there. Alright, next I'll go to the next power supply rail, which is RAM supply. Alright, so I give power. Hold on, let me see what's going on. I give power. Give me capture. Alright, so I'll have to clear. Alright, so let me go again. Oh, my power is plugged out. That's why. Let me go again. Alright, so this doesn't refresh automatically. Let me go again. Not capturing anything there. Falling edge, trigger level. Let me go again. Not capturing anything. Let me pause and see what's going on. Okay, so I have to set up the oscilloscope properly and my power was keep on plugging out of the unit. Alright, so I'm going to give power again. So next we have I'm going to check 5 volts. So I'm going to take 3.3 volts. This should be the output. Okay, so let me take a closer look at that. As you can see, 3 volt is coming out and falls. That's normal because 3.3 volt is generated before the switch, right? Because of the deep sleep. So 3.3 volts has to be always there at that coil. So it is sensing something that it's triggering off and turning on, and then slowly the voltage is dropping and discharging the filter capacitor there, right? So that's normal. Let me check RAM supply. Okay, so RAM supply is generating and falling. Alright, so let me trigger off channel 1 and go again. Alright, there we go. So as you can see, SLPS3 is okay. SLPS3 is okay there. Let's go again. Alright, so SLPS3, right, and they're falling, it's falling and discharging, so that's no problem there. Alright, CPU core, no CPU core supply. Yes, CPU core is out. Let's go again. Alright, let me check again. I was just testing with my fingers, making sure that I'm capturing. Alright, CPU core is not generated. Alright, VCC IO. Oops, that's the back end side. VCC IO is also okay. No problem there on VCC IO. So SLPS3 is okay. 5 volt is okay. Let's go again for 5 volts. Sorry. See, 5 volts is okay. It powers and discharge because of the filter capacitor. SLPS3 is generated and discharge okay. So let's check the secondary supplies, secondary 3 and secondary 5. I don't find any problem there. So secondary 3 and secondary 5. Okay. I don't see any problem there. Next one. That's okay. Alright, secondary supplies are okay. Let me confirm the secondary supply again. All good. This one. What's going on? Alright, that's good. This one. Oh, this is that's PP bus. I don't see any problem so far. All is well. All secondary supplies. Let me see under the tape here for SLPS3 that I taped down if I covered any of them. That's good. Alright, so I have another power supply here, which is 1.5 volts, I believe. That's also good. No problem there. Alright, so there's no problem. Alright, so I don't see any issue there with SLPS3 and all power supplies and the secondary supplies. Alright, so they're all generated. Except for CPU core, I haven't seen anything for the CPU core. Right, so I'm checking, as you can see, all the secondary supplies are. Hey, that's a short. I did measure that one then. Let me see. Let me see. Maybe it seems I missed that one. All right, so I'm going again. All right, so give power. Didn't capture anything. Okay, it's working now. Let me go again. I'm not capturing anything there. Am I grounded properly? Yes. SLPS3 is selected. Yes, it's connected. Not capturing that signal there. Alright, so see what's going on again. Nothing there. Okay, so my oscilloscope was calibrated incorrectly. So I was getting a wrong reading. So it's now calibrated. So let me start all over again. Alright, so 5 volts. This is PP5 volt S4. Alright, so as you can see, 5 volts has dropped before SLPS3 there. Right, so that indicates, as I said before, there is a problem there on the power supply. So SLPS3 is okay. So 5 volts falls before SLPS3. Right, RAM supply also falls before SLPS3. Right, see, as you can see. All right, CPU core hasn't generated. This is the VCC IO and the bus power supply. As you can see, it also falls before SLPS3. Right, as you can see, there's a problem there. Right, so on the secondary supply, secondary 3.3 volts. Right, also falls. Right, and here another secondary 3.3 volts. As you can see, it falls way below 3.3 volts and 5 on the other rail. Sorry. So this is the first secondary standby. As you can see, the time it has fallen. So that's roughly 5 milliseconds before, and this one has dropped roughly 5, 10, 15, 20, 25 milliseconds before SLPS3. Right, so that indicates that there's a short there. Definitely there's a problem there. So my oscilloscope was calibrated incorrectly. So as you can see there, right, let me check PP 1.8 volt S3. Let me head over to the schematic. Alright, so PP 1.8 volt S3. Let me go to the schematic first. PP 1V8 underscore S3, if I get it right. Oh, I put the wrong thing here. What is this? Alright, let me remove not found. Yes, it's correct. Alright, so we have PP 1.8 volt there. We have that for the camera. Cam 1.8 volts cam, that's pull up. That's a pull up line. That's another cam. So this board doesn't use 1.8 volt S3. Yes, it should. 1.8 volt, 1.8 volt, 1.8 volt, 1.8 volt. And that's a pull-up line. And that's for cam, no stuff. And that's a pull-up line there. And it's coming out of this section here. So it's not used. So this board doesn't use PP 1.8 volt S3. So that concludes all my power supply rails. So there's that short there. My oscilloscope was giving me incorrect reading. I didn't calibrate it properly. So we have a short here at the oscilloscope. As you can see right here is a short. So let me head over to the schematic with the board view and pinpoint where exactly that short is. And that's right under here. Here is the short. And it's PP3V3S0_FET, and this side is S0. So we have a short here. So I'll have to inject and burn the board. To see what's causing that short. So I was correct. It is a short on the rear stage of the board, secondary supplies. PP3V3S0 is shorted. So I'm gonna run a wire there. All right. Now let's head over to the thermal camera. All right, so I'm now on the camera. All right, so I'm going to seek and then check. All right, so let me check in the dead center of the board here first. So I'm going to give power. All right. Let me check here. Is that? Let me check on the other side. All right, so I'm going to give power again. Oh, it's not grounded. Oh, sorry. We don't have ground. The ground was slipped off. All right, there we go again. All right, so I give power. Aha, we have a hot spot right there. And it's pointing to that spot. So maybe it's on the next side of the board. All right, so it's indicating that it's somewhere right here. Let's give power again. Aha, and what is that? Oh, it's that small cap there beside the audio. It's that small cap there beside the audio section there. All right, so that seems like we are getting somewhere. All right, let's remove this wire. Oh no, I can't remove it yet, so I need to confirm it with some 99.9 to see the evaporation. And so it was pointing right here. That's having a short. So could it be that it's this cap here? Let me move this underfill epoxy. Alright, so I'm gonna just add some 99.9. Did I break something there? Oh, yeah, I ripped out a cap there. Alright, so I'm gonna add some 99.9 right here. Yes, it is. As you can see, it's getting hot there. See? So it's the cap. That little cap there was the culprit, causing the power failure on the rear stage. So I remove. Alright, so that is removed. Let me remove the rest of this underfill here, so as I can solder another cap there. I need back this cap as well. This is an audio. Alright, so I exposed these solder pads here so I can replace with my new cap. All the 3 minutes gone in the video. Yeah. Alright, so I'll put back the small one here and my new cap. Alright. Alright, done. And then I'll get another 0402, and that was a 0201. So let me check the rail. Let me check. If the short is gone. Yeah. Alright, so yes, it's gone. It's now restored. So I can remove. And I can remove my SLPS3 cable as well. Alright, so I'll now add the new cap. Alright, there we go. Okay, so I'll now connect the DC jack and add some power to the board. Now setting back the voltage back to 19 volts. 20 volts is fine. So I will okay, so I will now connect power. Alright, so I give power. As you can see, it's now 700 milliamp there, 800, and that seems the job is done. Fan is spinning. Alright, so we'll check 5 volts. Yes, 5 volts is there. Let me adjust this. The glare, I think it's too bright. Alright, 3.3 volts. Yes, 3.3 volts is there. RAM supply, 1.35 volts, DDR3. 1.8 volts for the RAM or 1.6 for the CPU. 1.7, 1.05 volts is okay. Excellent for the CPU core. Right, and we have secondary 3.3 volts that was shorted. PP3B3 volts S0. Excellent. Right, we have 3.3 volts. We have PP bus there. Right, and 3.3 volts SLPS0. Excellent. Right, and all is well there. 1.5 volts are here. Excellent. 1.5 volts is there. So we have all power supplies. So I will assemble back the unit now. Right. I'll just pause, sake of time. Okay, so I'm at basically the last step of the assembly. Alright, so I'm connecting the battery. And then put back this tape that I saw. Alright, so double checking, making sure that everything is connected. All right. Okay, so let's wait for the chime. Battery may be dead. Seems the battery is dead. All right, the current is there, 900 1 amp. Ah, that sound is so refined. And there we have the Apple logo there. As you can see, its progress bar is loading. Okay, it's taking a little while. It's taking a while. It's moving. It's a bit slow. Oh, we have mouse. I just saw the trackpad mouse. Oh, okay. Seems like it has a lot of stuff on it. Most likely it has a pin lock on it as well. There we go. So we're there. Right, so it's now in operation there. And it's ready to go. Alright, so I'll turn it off. And the job is done. Alright, so I hope you enjoyed the video and I hope you learned something, especially with the oscilloscope there, using the 2 channel to capture the power failure, right? And that the oscilloscope is a very crucial and important device that is used in the field of maintenance, right? And I'll see you again in another video. Alright, bye.